In this video, we are going to learn now about adding and subtracting rational expression with the same denominator, and we are going to find as well the least common denominators if the rational expression have different denominators. So if we are going to add rational expression if they have the same denominator, it's okay, you can already subtract and add rational expression. For example, we have p over r plus q over r equals p plus q over r. And then we have p over r minus q over r will give us p minus q over r. Okay, so therefore you don't need to find the least common denominator for these problems. Example, adding 4p minus 3 over 2p plus 7 plus 3p plus 8 over 2p plus 7. So from here we can see that two fraction or two rational expression have common denominator. So therefore what we're going to do is just add 4p plus 3p. Then we can get now 7p plus 5 over 2p plus 7. So here we cannot factor out anymore because they don't have any common factor, so therefore that will be your final answer. Next, if we're going to subtract 8y over y minus 2 minus 16 over y minus 2, so therefore you will have now 8y minus 16. And then here we have the common factor of 8. We can still factor 8y minus 16, which is 8 times y minus 2 over y minus 2. So therefore we have two common factors now. And then after that, eliminate the two common factors, which is the answer now is equals to 8. So therefore, when you are going to subtract and add, if the expression can be factored out, so therefore factor it out. And then write the least solution. Subtract the following rational expression. So we have 3y over y squared plus 3y minus 10 minus 6 over y squared plus 3y minus 10. How will we solve this one? So therefore we will have now 3y minus 6 over y squared plus 3y minus 10 because both of them have common factors or common denominators. And then after that, find the common factor. So therefore we will have now 3 times y minus 2. The denominator part will be y plus 5 times y minus 2. And then we can cancel out or eliminate y minus 2 over y minus 2. Therefore your answer now will become 3 over y plus 5. So to add or subtract rational expression with unlike denominators, you have to change them to equivalent forms that have the same denominator or common denominator. This involves finding the least common denominators of the two original rational expression. So to find the least common denominator, first thing we will do is factor the given denominators, take the product of all the unique factors, and then each factor should be raised to the power equal to the greatest number of times that the factor appears in any one of the factor denominators. Find the LCD of the following rational expression. For example, 1 over 6y and 3x over 4y plus 12. So therefore, we are going to find now what are the factors of the two equations. So here we have 6y, and then the other side we have 4y plus 12. We can factor out that one as 2 times 3y, and then the other one we can factor out as 2 squared times y plus 3. So therefore your common factors now, or your common denominator, will give us 12y. Okay, so here 12y, and then we can have now as y, okay, y plus 3. Because we have 2 squared, and we also have here 3y. So that is 4 times 3, which is equals to 12. And then after that, we have 12y now. So therefore, the The other factor is y plus 3. So therefore the LCD now is 12y times y plus 3. Next, how about if we have 4 over x squared plus 4x plus 3 and 4x minus 2 over x squared plus 10x plus 21. First thing you will do is find the factors of two denominators, which is x plus 3 times x plus 1, and the other one we have x plus 3 and x plus 7. So here we can see that there are two common factors, which is x plus 3. So we are going to use only one x plus 3. But there are two different factors. Therefore, our LCD now will be x plus 3, x plus 1, and x plus 7. Another example. We have 3x over 5x squared minus 5 and 4x squared over x squared minus 2x plus 1. So what are the factors of the two denominators? So here we can have now as common factor is 5, right? You take out 5 there, so therefore you will have now as 5x plus 1 and x minus 1, because x squared minus 1 is also the same as x squared minus 1 squared. Okay, and then this one will give us a minus b and a plus b equation, which is the difference of two squares. And then the other one we can have now x minus 1 squared. So here we can observe that we have 5x plus 1 and x minus 1, and then here we have 1x minus 1. So therefore your common denominator now will give you x plus 1 times 5 times x minus 1 squared. Okay, last one. We have both of the denominators are already factored. Since each is the opposite of the other, you can use either x minus 3 or 3x or 3 minus x as the LCD. Okay. To change rational expression into equivalent forms, we use the principle that multiplying by 1 or any form of 1 will give you an equivalent we have expression. So we have p over q equals to p over q times 1, which is p over q times r over r. And then after that, we can get common factor, which is r over r. So that will lead you to p over q. Rewrite the rational expression as equivalent rational expression with a given denominator. So for example, we have 3 over 9y to the power of 5. So what is the denominator? So therefore, when we are going to check that one, we're going to find which factor or which number we multiply, okay, to 9y to the power of 5 to become 72 9 to the power of y to the power of 9. So we can see that it multiplied by 8y over 4, or y to the power of 4. So therefore, we multiply as well the numerator part with y, 8y to the power of 4. Therefore, the result will become 24y to the power of 4 over 72y to the power of 9. Now, let's do adding and subtracting rational expression with different denominators. Okay, unlike denominators, as stated in the previous, we have explanation or section. To add or subtract rational expression with different denominators, we have to change them to equivalent forms, or you are going to find now the LCD, which is the least common denominator. So find LCD, rewrite each rational expression as an equivalent one with the LCD, and then after that add and subtract, and then simplify your rational expression. Example. So let's say we have 15 over 7a and 8 over 6a. So what are the common factors, or what is the LCD of 7 and 37, and we have 6. So we will have now multiplied as 6 over 6 and then 7 over 7. So we will have 90 over 42a, because our LCD is equals to 42a. So therefore, we will have now as 146 over 42a, or we can simplify as 73 over 21a. So first thing you will do is find the common, we have denominator of 7a and 6a, which is equal to 42a. And then after that, we're going to find now a number that will multiply to 6 and 7 to become 42. Okay? Next, subtract the following rational expression. 5, and we have 5 over 2x minus 6 and 3 over 6 minus 2x. So therefore we will have here 5 over 2x minus 6 minus 3 over 6 minus 2x, which is the same as, we can use as 2x minus 6 plus, we're going to change that one because you're going to multiply this one by negative 1. So therefore it will become now as addition, and then will give us 8 2x minus 6, and then factor out 2x minus 6 to become 2 times x minus 3, and then common factor here, we will have now 4 over x minus 3. Okay, so remember that if we are going to change this one into a positive form, the 6 minus 2x, we are going to multiply that one by negative 1. The negative 1 times a negative here, that will become positive value. So therefore we will have now as 2x minus 6 as denominator. Okay, let's see, we have this one. What about if we are going to subtract now a rational expression minus a whole number? So what we're going to do, so we are going to find an equivalent denominator here, because this one is equal to 3 over 1. So 7 over 2x minus 3, that will give us now 7 over 2x minus 3 minus 3 times, you multiply this one by 1, which is 2x minus 3, the denominator. So therefore we can have now as this common denominator 2x minus 3. And then after that, distribute first, so that it will give you 7 over 2x minus 3 minus 6x minus 9 over 2x minus 3. That will lead us to 7 minus 6x plus 9 over 2x minus 3. And then simplify it to simplest form, and then you can change that one into the other side, so that we will have now as 16 minus 6x, or you can have now 6x, move on the other side, right? 6x minus 16x, but this doesn't have common factor, so just leave your answer that way. Add the following rational expression. So for example, we have 4 over x squared minus 6, or x squared minus x minus 6, and x squared plus 5x plus 6. What is a factor of this one? We can have now as x minus 3, x plus 2, x plus 3, x plus 2. So here, there is two common factor, x plus 2 and x plus 2. So we're going to use only x minus 3, x plus 2, and x plus 3. So what are the numbers that are not in the first one? Okay, here x minus 3, x plus 2. So we don't have here x plus 3. So you multiply the numerator with x plus 3. And then on the other side, we don't have x minus 3. So therefore, you multiply x by x minus 3 and simplify it to the simplest form. So we will have now 4x plus 12 plus x squared minus 3. And then after that, x squared plus, we have plus x plus 12. And then here we cannot factor out this one anymore. So therefore, guys, when you observe, x plus 3 don't cancel out x plus 3 and x plus 3, and then x minus 3, x minus 3. No, that is wrong process. You have to distribute first before solving and simplifying, because this one is our denominator. You don't need to cancel out or eliminate x plus 3, x plus 3, x minus 3, x minus 3. Okay? Next, solving equation containing rational expression. So we are going to solve the value of x, or the variable containing we have rational expression. For example, the first thing we'll do is note that the equation contains an equal sign and an expression does not. So every time, for example, in linear equation, you will going to equate the equation into 0, but the expression does not have an equal sign. To solve equation containing rational expression, clear the fractions by multiplying both sides of the equation by the LCD of all the fractions, then solve the same as in the previous section, which is you're going to simplify to the simplest form. Okay, for example, 5 over 3x plus 1 equals to 7 over 6. We will equate this equation now into 0, or you can have now simplify the fraction so that you can eliminate the fraction. So therefore, the common factor here is 6x, which is the 3 and 6 common factor is 6, and then we have the x, we will put x as well. So therefore, you will multiply both sides. So therefore, we can have now as 10 plus 6x, which is this one is 2 times 5 is 10. Then 6x times 1 is 6x. And then here we will have 6x times 7 over 6, which is equals to 7x. And then here you can solve already for the value of x, which is x is equals to 10. When checking, just let x equals to 10, and then after that we will see the result, which gives us equal to each other. Okay, so 1 over 6 plus 1 is equals to 7 over 6. Let's try another example. For example, we have 1 over 2x minus 1 over x plus 1 equals 1 over 3x squared plus 3x. How will we solve this one? So therefore, we will have now as the common factor is 6x times x plus 1, which is the 3 here. You can factor this one out as 3x times x plus 1. Okay, so here we can factor that one out as, okay, this one, right? The 3x squared here, we can write that one as 3x times x plus 1. So therefore, we have here 2x and 3x. So what is the common factor, or LCD, least common denominator, of 2x and 3x? So therefore, we can have now as 6x, and then x plus 1, x plus 1. So therefore, you are going to multiply everything by 6x times x plus 1, and then simplify it to the simplest form. So therefore, the result is 3 times x plus 1 minus 6x equals 2. And then after that one, simplify, distribute 3x times x plus 1, we get 3x plus 3 minus 6x equals 2. Then after that, 3x minus 6x, we will get negative 3x, and then move 3 there on the other side. That will give us negative 1, and then x is equals to 1 over 3. To check that one, substitute 1/3. So 2 over 1 over 2 times 1 over 3, 1 over 3 plus 1, and here on the other side 1 over 3 squared plus 3 times 1 over 3. So therefore, your equation now will give you 3 over 2 minus 3 over 4 equals to 1 over 3 plus 1. The result is equal to each other. Okay, so therefore the solution for that equation is equals to 1 over 3. So doing solutions or solving mathematical problem is what I've said, just only a constant practice. You're going to practice every time. Practice some of the problems so that you can remember, you will be familiarized about it. Okay, last example. Let's say we have x plus 2 over x squared plus 7x plus 10 equal to 1 over 3x plus 6 minus 1 over x plus 5. What is our common factor? What is the factor of x squared plus 7x plus 10? And then here we can still factor out this one as 3 times x plus 2. So therefore here the common factor is x plus 2, x plus 5, right? So therefore we can have now as 3 times x plus 2 times x plus 5. And then after that, simplify into the simplest form. So here we can cancel out that one. The remaining is 3 times x plus 2. Here we can have well, if you are going to multiply, that's 1. So cancel out 3x plus 6 times x plus 5. So that's the reason why we have x plus 5 here. And then on the other side, minus, we don't have x plus 5, cancel out x plus 5, eliminate x plus 5 here. So therefore, you will have 3 times x plus 2. And then simplify to the simplest form. So we will get 3x plus 6. And then after that, equal to x plus 5 minus 3x minus 6. And then simplify to the same variable. We can get now as x equal to negative 7 over 5. The same process when you are going to check, when you are trying to check your solution. So you just simply substitute the value of x into negative 7 over 5. Okay, so the checking right goes this way. And then after that, after checking, so the result is the same. Okay, so please try to practice more about solving equation involving rational expression and also solving rational expression with fractions and then also with equations.